Alright, so in this video we're going to look at exponential and logarithmic equations. We're going to solve these 6 examples. This is all we're going to do, is these 6 examples. What I'd encourage you to do is, I would pause the video now, see if you can do these without me doing it for you, and then check your answers by rewatching the video. The 2 with the red dots next to them, those are going to require a calculator. The rest of them do not require a calculator at all. You can do the rest of them, just with some mental math. So we're going to get into it. If you've already paused and tried to figure them out, great. If not, if you don't know how to do any of it, then follow along. I would be willing to bet that if you worked at a few of these, you could probably figure them out at this point. Okay, so the first one, 3 to the x equals 25. What we're going to do whenever you have an x in the exponent, the whole reason we have logs is to figure out how to solve when x is in the exponent or a variable is in the exponent. So what we're going to do is there's 2 ways to do this. You can convert it to a logarithm, or we're going to, what's easier, take the log of both sides. So just like you can square both sides, you can square root both sides, you can multiply by 10 on both sides, you can log both sides as well. So this becomes log of 3 to the x equals log of 25. And when I say log, it's assumed that it's base 10. That's what our calculator is base 10. And you don't have to write the 10 there if you don't want to. So then, one of the tricks we learned is if you are taking the log of something and it has an exponent, that exponent can get pulled out in front. So we have x times log of 3 equals log of 25. So that's the whole reason we use logs, is because the only way to solve when x is in the exponent is using logarithms. All right, so then I'm going to divide by log of 3 on both sides, and we get x equals whatever log of 25 divided by log of 3 is. Now, it is tempting to want to say, well, can't we just cancel out the logs? No, you cannot do that. You have to figure out what the log of 25 is and the log of 3, and then divide them. So I'm going to pull up my calculator here. Do log 25, close parentheses, divided by log 3, close those parentheses. So this is 2.9299. So if I rounded, excuse me, if I rounded, it'd be 2.930. All right. So 2.930. All right. Okay, first one in the books. Next one. This one is quite a bit different than the previous one. Here we have a log equation. That was an exponential equation. And on this one, we have log base 7 of 4x equals log base 7 of 36. So this is one where you really don't even have to know how logarithms work to be able to figure this one out. All you have to know is what this equal sign means. And the equal sign means that everything on the left has to be the same as everything on the right. So if this equation is log base 7 of 4x, then the one over here also has to be log base 7 of 4x. But it's log base 7 of 36, so that means that 4x is going to equal 36. So if I solve this, it would be 4x equals 36, divide by 4, and we get x equals 9. Easy peasy. Now, one thing I would strongly encourage you to do is plug it back in to make sure that it indeed does work. So we have log base 7 of 4 times 9 equals log base 7 of 36. And 4 times 9 is indeed 36, so this is log base 7 of 36 equals log base 7 of 36. So that does check out. We'll see in a little bit that it doesn't always check out when you solve it using your algebra. Okay, next two. This example is pretty much just like the last one, so we'll go through it fairly quickly. They're both log base 4. One's log base 4 of 2x plus 9, one's log base 4 of 5x plus 27. That equal sign acts as a balance. That means everything on the left is the same as everything on the right. So 2x plus 9 is going to equal 5x plus 27. Okay, now I'm going to solve it, just like we did on the last one. This one's going to require a couple steps, so I'm going to subtract 2x first. I get 9 equals 3x plus 27. Then I'm going to subtract 27. I get negative 18 equals 3x. Divide by 3, I get negative 6 equals x. All right, so I'm going to plug this back in. And so this becomes log base 4 of 2 times negative 6 plus 9 equals log base 4 of 5 times negative 6 plus 27. All right, so log base 4 of negative 12 plus 9 is negative 3. And this would be log base 4 of negative 30 plus 27 is negative 3. Now, at this point, I would say most students would say, great, it checks out, they're both equal. But there is a problem here. These two things are not possible. Oh, whoopsie, I didn't mean to do that. I wanted to grab the highlighter. You cannot do log base 4 of negative 3. Because what this is saying is it's saying 4 to what power is negative 3. And so you might think, well, it's got to be a negative number because let's say we did 4 to the negative 1. Well, actually that's 1/4. 4 to the negative 1 is 1/4. If I did 4 to the negative 2, that's 1 over 4 squared, which is 1/16. So no matter what exponent you put, if I try a positive number like 4 to the first, that's 4. The problem here is every single number that we get for an answer is positive. Well, we're never going to get something that is equal to negative 3. So here's the moral of the story. If you're ever doing a log of a negative number, that is not possible or undefined. It's something we can't do. So this is actually, the final answer to this one is no solution. Oops. No solution. So I know it may seem a little bit confusing because, when we plug it in, we get log base 4 of negative 3 equals log base 4 of negative 3, which is the same. But both of those expressions are not possible, so it would be considered no solution. Okay, so a little bit of a tricky one there. That's why we have to plug stuff in to check and see if we get log of a negative number. Okay, the next one. If we have the log of something subtracted from the log of something, we can combine those two things. And this becomes, I keep forgetting to switch to the pen, log base 9 of 12 divided by 4 equals log base 9 of 6x. So 12 divided by 4 is 3. Log base 9 of 3 equals log base 9 of 6x. And now it's just like the previous two problems where both of these sides of the equal sign are log base 9 of something. So that means that we can just take the 3 and the 6x and set them equal to each other. So 3 equals 6x. Divide by 6, and we get 1/2 equals x. All right, so if I choose to plug these in, we end up with log base 9 of 12 minus log base 9 of, ooh, that's an ugly 9, that's better, of 4 equals log base 9 of 6 times 1/2, which is 3, and it does indeed check out because the left side ends up being log base 9 of 3. All right, 4 down, 2 to go. The next one we also don't need a calculator for, but the last one we will. This one is log base 5 of 10x equals 3. So the big deal on the right side is it's not log base 5. If you notice, the one, it's just equal to 3. So we can't just kind of ignore the logs like we did on the others. we have to actually do something else. So what we're going to do is we're going to convert this from a log to an exponent. We're going to go zoop, 5 to the third equals 10x. And then we're going to solve it. So now it's actually not an exponential equation or a log equation at all. It's just a kind of basic algebra equation. 5 to the third, 5 times 5 is 25. Times 5 more, 25 times 5 would be 125. Think about it in terms of quarters. 5 quarters is $1.25. All right, and then we divide by 10. And this would be 12.5 equals, not 3, x. If I plug it in here, 10 times 12.5 is 125. Log base 5 of 125 is 3, so it does indeed check out. All right, last one. This one we will need a calculator for eventually, but we're going to do a few things before we get to that calculator step. So I want to get x all by itself. But in order to do that, I got to get rid of this minus 5 first. So I'm going to add 5. And I get 10 to the 2x plus 1 equals 12. Now I'm going to ask you this, and maybe you can say this out loud to your device, but how do we get x out of the exponent? What is the trick to solving if x is in the exponent? Feel like an episode of Sesame Street here. You know, I'm asking you a question, answer to the TV. So basically the answer is you take the log of both sides. If you recall, we do that so we can pull that exponent out in front. So this becomes log of 10 to the 2x plus 1 equals log of 12. So since this is our exponent, I can pull that out in front. We get 2x plus 1, I'm going to put that in parentheses, times log of 10 equals log of 12. Okay, since we're multiplying by log of 10, I'm going to divide by log of 10 to cancel that out. And then I'm just going to do the calculator all at once. So we've got 2x plus 1 equals log of 12 divided by log of 10. And then I'm going to subtract 1 from both sides. So I've got 2x equals, let's see, it's getting kind of messy here, log of 12 over log of 10 minus 1. And then I'm going to divide everything by 2. So I'm going to type all of this stuff into my calculator. Log 12 divided by log 10, subtract 1 from that, and then take that answer and divide it by 2. All right, let's do that. So let's see, log 12 divided by log 10, and then I'm going to subtract 1, so I get that, and I'm going to divide that by 2. So I get this pretty small number. It's 0.03959. So I want to round it to 3 decimal places. So that's going to be 0.040 if I round it correctly. So this would be x equals 0.040. It's approximately equal to, not exactly equal, as we saw. All right, hopefully you were able to get a couple of those. Hopefully that helped explain how to solve exponent and log equations.